We now discuss the solution of a problem from the section Integral Calculus, and the problem is on the evaluation of a given definite integral. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the second shift. The problem is, if integral 0 to pi sine cube x into e power minus sine square x dx is equal to alpha minus beta by e, integral 0 to 1 root of t into e power t dt, then alpha plus beta is equal to. So we are given a definite integral 0 to pi sine cube x into e power minus sine square x dx is equal to alpha minus beta by e into integral 0 to 1 root of t into e power t dt. So this is given to us. So that means we have to evaluate this integral, put it in this form. Then alpha plus beta is equal to, we have to find. We will now discuss the solution of the problem in detail. So that's our problem. A solution. Let I denotes the integral 0 to pi sine cube x into e power minus sine square x dx. We recall this result. The result is integral 0 to 2a f of x dx is equal to 2 times integral 0 to a f of x dx if f of 2a minus x is equal to f of x. That means the integrand is invariant by after substituting x by 2a minus x. If you replace x by 2a minus x, 2a minus x, fx remains the same, then it will be 2 times integral 0 to a f of x dx. If f of 2a minus x is equal to minus fx, then the integral 0 to 2a fx dx will be 0. So this is the result what we are going to use here. So for 2a here it is pi. So if you substitute pi minus x for x, the integrand remains the same. Therefore 2 times integral half of the upper limit, that is pi by 2 sine cube x into e power minus sine square x dx. For sine square x, we write 1 minus cos square x, and that is equal to 2 times integral 0 to pi by 2 sine x into sine square x. For sine square x, we have written 1 minus cos square x into e power minus sine square x, that is minus 1 minus cos square x dx. Now we substitute cos square x is equal to t. We substitute cos square x is equal to t. Differentiating, we get minus 2 cos x into sin x dx is equal to dt. And we want sin x dx. Sin x dx. So sin x dx will be equal to minus 1 by 2 cos x. Cos x is root to t dt. So sin x dx is equal to minus 1 by 2 root t dt. And we go back, and that is equal to, and what happens to the limits? What happens to the limits after substituting this one? Now, when x is equal to 0, t will be cos square 0. That is, cos 0 is 1, so t is 1. And when x is equal to pi by 2, cos pi by 2 is 0, t is 0. So the above integral becomes integral 2 times integration 0 to pi by 2 will become 1 to 0. 1 to integral 1 to 0. And sin x dx is minus 1 by 2 root t dt. minus 1 by 2 root t dt into this is 1 minus t and e power 1 minus t. And now this minus is taken care of, and we have taken out the minus and reversed the limits of integration. Instead of 1 to 0, we have written 0 to 1 and we have taken out a minus. Right, and that will be integral 0 to 1 minus t into e to the power of minus of 1 minus t, and that will be e to the power of t minus 1, and 2 cancels, and 1 by root 2 root t dt. So this is the one what is left out. And now we have succeeded in getting a integral 0 to 1 and in terms of e power t and root t. Yes, let's see what happens further. And that is what we have done. And for this e to the power of t minus 1, we write e power t into e power minus 1. E power minus 1 is 1 by e. So that will be 1 by e integral 0 to 1 minus t e to the power of t 1 by root t dt. Very good. Now separate them. That is 1 by e into integral 0 to 1 times e power t 1 by root t dt minus integral 0 to 1 t root t. T in the numerator, root t in the denominator, that will get root t in the numerator. So root t e to the power of t dt. This is what is appearing in the answer. Right, very good. Now, to integrate this one in blue, we apply integration by parts. So that this is the first function, this is your second function, and that will be equal to 1 by e, first function, and integral of the second. This is the integral of 1 by root t, minus integral 0 to 1 differential derivative of the first e power t, d by dt of e power t into integral of the second. This is the same thing what we write here, minus this integral is left as it is. And now we simplify, and that is equal to 1 by e into, and this will be 2 root t minus 1 by 2 plus 1 is 1 by 2. That 1 by 2 becomes 2 into root t to be evaluated between the limits 0 to 1. And this one is minus integral 0 to 1 derivative of e power t is e power t, and this is 2 root t e dt, and this is one and the same, except that this is 2 times of this one. And when you add, this will becomes 3 times of this integral 0 to 1 root t e power t dt, and this is to be evaluated. That is 1 by e into, for the upper limit t is equal to 1, e into 2e, minus for the lower limit t is equal to 0, root t becomes 0. That is 0 minus 3 times integral 0 to 1 root t e power t dt, and this 1 by e is taken inside, and that will be 2e into 1 by e is 2 minus 3 by e integral 0 to 1 root t e power t dt. Good. And this is given to be alpha minus beta by e integral 0 to 1 root t e power t dt. Now comparing the corresponding terms, you get alpha is 2 and beta is 3. So this will imply alpha is equal to 2, beta is equal to 3. And we are required to find what is the value of alpha plus beta. So alpha plus beta is 2 plus 3, that's equal to 5. That's our answer. The answer is 5. So the answer is 5. That is the discussion of the solution of the problem from integral calculus on definite integral, and it is not that difficult to integrate such functions. But however, it is a interesting question, and go on working out some more problems on these lines. and I am sure that you have understood it. And practice, practice, that makes a man perfect. I wish you all the best. Thank you.